In the third part of the Excel tutorial, we're going to learn how to fill out the economic feasibility sheet. To start with, let's fill out the discount rate as 10%. Now, from the concepts learned in the previous section, we know the recurring value of benefits in the first year of implementation is 0. From the second year onwards, the recurring value of benefits is as given in the total in the recurring benefits sheet. To copy it, we put an equal to sign, select, and enter. Since the value is the same in all 5 years, we want to autofill, but in this case it must be an absolute cell referencing because we want to hold both the row and the column constant. The present value factor is given by the formula 1 divided by 1 plus discount rate raised to the power year. Now, again, in this case, the discount rate is an absolute cell reference because the row and the column must be held constant. However, the year is a relative cell reference because it changes according to the value in row 4. So we will use autofill again. To fill in the present value of benefits, use the following formula. Multiply the recurring value of benefits with the present value factor. Now, to populate the present value of benefits, you just multiply the recurring value of benefits into the present value factor. And in this case, both the cells will be relatively referenced because we want to multiply C6 into C7, D6 into D8, and so on. So autofill using relative cell referencing. Finally, the net present value of benefits is a cumulative total of all benefits in that year. So for the first year, it is the same as the present value of benefits. In the second year, it will be a sum total of the present value benefits in that year plus the present value benefits of the previous year. Again, this is a formula that will be copied across all the cells, and for both the cells it will be relative cell referencing. So we can go ahead and do an autofill, and what we see is that H9 must be equal to G9, which is a positive figure because it's benefits. We now fill up the costs. Remember from the last time that one-time costs only applies in the first year of implementation. So we will copy the total one-time costs from the sheet one-time costs into the cell. For the following years, the cost will be 0. To fill out the recurring costs, we will enter 0 in the first year, but in cell C14, we will copy the value from the recurring cost total in the recurring cost sheet. Again, in this case though, this will be absolute cell referencing, so we want to hold both the column and the row constant. Go to the corner and drag for autofill. The present value factor is the same as above. You can simply say equal to B7, enter, and then autofill all the way because it's relative cell referencing. To calculate present value of costs in the first year of implementation, simply multiply one-time costs with the present value factor. But for year 1, you want to calculate it as a recurring cost into present value factor. Again, because it's relative cell referencing, you can autofill directly. To calculate net present value of all costs, for the first year, it is the same as the present value of costs above as before. But for the second year, it is C16 plus B17 as a cumulative total, And because it is a self-referencing, you can simply autofill to get the final costs. Again, H17 is equal to G17. Now the overall net present value is the net present value of benefits minus net present value of costs. But because the costs are already negative, as you will remember from part 1, that's how we had set it up, you can simply say net present value is benefits plus costs. Enter. Again, it is relative cell referencing, so go ahead and autofill and set H19 is equal to G19. This is a positive value, which means this project at a 10% discount rate with a break-even of 5 years is a feasible project. But we have one more thing to do. We want to make the break-even chart. To fill this out, the first thing you want to do is to copy the overall net present value from the economic feasibility chart and then autofill using relative cell referencing. Now, select all the data on this chart. Now, select all the data in this sheet. Go to Insert and look for the scatter chart. Click on the arrow and select Scatter with Smooth Lines. Now notice how there's a $0 line for the net present value on the left hand side. So the y-axis is the net present value. The x-axis is the number of years. Notice that right between the end of the 4th year and somewhere in the 5th year, the net present value crosses the $0 line and becomes positive. This exact time is your break-even point. Now let's go ahead and add data labels. Right click, add data labels, and there you have it. You can now say that the SAP implementation will be feasible for the given values at a discount rate of 10% and break even of 5 years. This concludes the main analysis of your assignment. This is what you'll be required to do in your assignment. However, there are certain other things that you should know before you attempt the assignment. Changing any of the costs or benefits is going to change the net present value and the outcome of feasibility. For example, if you were to change the discount rate to 15%, while the net present value would still be positive, it would be a smaller number. If you change it to 25%, the net present value overall would be a negative number at the end of 5 years, and the project would become unfeasible. Similarly, changing the costs or benefits will reflect automatically in these values here and impact your overall feasibility result. This concludes our Excel tutorial.